Hello students, so in today's video we are going to understand the concept of limit and continuity of a function. So let's start with the limit and we further move with continuity. So let's say we have a function, mathematical function fx, and we are talking about its limit at a given point x equal to a. So mathematically we write it like this: limit x tending a fx. So this is a representation for limit of fx at x equal to a. So what is the meaning of limit at x equal to a? Suppose we have the graph of the function like this. This is our x-axis, this is y-axis, and this is our origin. So suppose the graph of the function is like this. Okay, so I have made intentionally the graph like this. It is broken in between. So suppose this is our point x equal to a. So as we approach towards point x equal to a from left side, the function's graph is going towards this point. So this is the point. Suppose I say this is point L1, and as we are approaching, so this was the point towards which the function's value was approaching as we approach towards point x equal to a from left hand side. Similarly, suppose as we approach towards the point x equal to a from right hand side, the function's value approach towards some other point. Suppose this point is L2, and the actual value of the function at x equal to a, that is given by this value. So this is your fa, value of the function at x equal to a. So here what you will write the limit. So as we are approaching towards the point x equal to a from left hand side, the function's value is approaching towards L1. So you will write left hand limit of the function, or mathematically we can write it like limit x tending to a minus fx. This is equal to L1. Similarly, as you approach towards the point x equal to a from right hand side, the function's value approaches towards the point L2. So you will write the right hand limit of the function, or RHL, is equal to, which can mathematically be written as x tending a plus fx, that is equal to L2. So in this particular example we have taken L1 is your left hand limit and RHL is L2. So we note here that L1 and L2 are not equal, and also function value at x equal to a, that is fa, little different from these two values L1 and L2. So in this case the function is neither continuous nor its limit exists. So when do you say the function's limit exists? So when left hand limit LHL is equal to right hand limit RHL. When LHL is equal to RHL, then we say that function's limit exists and what is the limit of the function? Limit of the function will be written like this: limit x tending to a fx is equal to whatever value it was. Suppose I say LHL is equal to RHL is equal to L, then this will be your limit of the function. Okay, and also for continuity, what do you write? I say if LHL is equal to RHL and this is also equal to value of the function at that point x equal to a, then you will write the function fx is continuous at x equal to a. So for continuity, the function's left hand limit, right hand limit, and value of the function at that point, all these three should be equal. But for the existence of limit, only left hand and right hand limit need to be equal, and that value becomes the limit of the function at that point. So I hope you understood this. So we can understand this by one example. So let us take one mathematical example here. Fx is equal to x square minus 4 divided by x minus 2. So question is, find limit of this function at x equal to 2. So find limit x tending to 2 fx, and what should be value of fx at x equal to 2 so that fx is continuous at x equal to 2. This is our question. Okay, so first step is, what is the limit of this function? Let us see. So we will make a table here to find the left hand and right hand limit. Okay. This with x value and corresponding fx value. Similarly here also x value and fx value. So why we have made these two tables? So in one table we will approach towards the point x equal to 2 from left hand side, and in another table we will approach towards the point x equal to 2 from right hand side. So let's write suppose we are approaching towards the point x equal to 2 from left hand side. So we will be on the left hand side of point 2. So the points are, and we are going towards point 2, so close to point 2. So let's say x is equal to 1.9. Further we go closer to x equal to 2, so 1.99, 1.999 and 1.9999, and further very close to 2, 1.99999. Okay. Similarly, we can come towards the point x equal to 2 from right hand side also, and suppose you are close to point 2 but on the right hand side, so will be slightly larger than x equal to 2. So suppose it is 2.1, further close to 2, so 2.01, 2.001. We are coming closer and closer towards point 2, so 2.0001, and at last 2.00001. Okay, now we will find what is the value of this function x square minus 4 upon x minus 2. So you can note here that the function is not defined at x equal to 2, because if you put x equal to 2 in this function, it will make the denominator 0 and the function undefined. So we can't put x equal to 2. So you say that fx is not defined at x equal to 2. So if a function is not defined at x equal to 2, definitely it is not continuous at x equal to 2. So originally this function is not continuous, because as I said, for continuity the limit of the function should exist and its value at the point should also exist, and both should be equal. But here, as the value of the function at x equal to 2 is not existing, so this function cannot be continuous. So let's find the value of this function at these x values we have mentioned in these two tables. So for 1.9, if you will put it here, x equal to 1.9, you will see that you will get fx equal to 3.9, and for 1.99 it will be 3.99, then 3.999, 3.9999, and finally at x equal to 1.99999, you will get fx equal to 3.99999. So what do you see here? As you are approaching closer and closer towards x equal to 2, towards what value of fx is approaching? You can notice that fx is approaching towards point 4, right? Similarly, if we put x equal to 2.1, as we are talking about the right hand side table, if you put x equal to 2.1, you will get fx equal to 4.1. For 2.01, if you put in this expression, you will get 4.01. Similarly, for this you will get 4.001, 4.0001, and at last for 2.00001, you will get fx equal to 4.00001. So again you see that as x value is approaching towards 2 from right hand side, fx value is approaching towards 0.4. So in both cases, either you are approaching towards point x equal to 2 from left hand side or right hand side, the function's value is approaching towards the same point. So this left hand side will implies that the left hand limit of the function is 4, and right hand side table implies that right hand limit of the function is also 4, and you see that both limits are equal. So you will say that limit of the function, limit of fx at x equal to 2 is equal to 4. So limit of the function is 4, and mathematically you can write it like this: limit x tending to 2 fx is equal to 4. So in this particular example, left hand limit means left hand limit x tending to minus limit fx is equal to 4. Right hand limit means limit x tending to plus fx, this is also 4. So we found that limit of the function is 4 at x equal to 2. So this is first answer of our question. And now we have to define the function. What should be the value of the function at x equal to 2 which makes it continuous? So as you know, for continuity, the left hand limit of the function that must be equal to right hand limit of the function, and it must be equal to value of the function at x equal to a. So for continuity, you saw that left hand limit is equal to 4, right hand limit is equal to 4. So for continuity, function's value at x equal to 2, that must also be equal to 4. So for continuity, the function's value at 2 must be equal to 4. And so now the function can be defined in pieces, because original function was not defined at x equal to 2, so that was not continuous. So a continuous function can be defined in pieces like this. For x not equal to 2, the original definition can be given x square minus 4 upon x minus 2. But for x equal to 2, what should be the value of the function? It should be 4. So this function now is continuous at x equal to 2. So for this function, the graph will be continuous everywhere, and if you will plot the graph, it will not be absent anywhere. Like this I have drawn here. So graph of this function x square minus 4 upon x minus 2, if you draw, suppose this is x equal to 2 and this is 0.4. So for this definition, this new definition, the graph of the function will be, well, this is 1, this is 2. For new definition, the graph of the function will be like this. At x equal to 2, it will be 4. But for the original definition, if you draw the graph, the function graph will be same everywhere, but there will be a circle at x equal to 2. It will not be defined at x equal to 2. Okay, I hope you understand what is the limit of a function, what is the continuity, and what is the physical interpretation of the limit of a function. So I hope you enjoyed this video. So if you enjoyed it, like my video and subscribe my channel and keep watching it. And if you find any doubt or any concept problem or any question, just keep it posting on the comment section. I will try my best to answer those questions. Thank you very much. Take care and bye.